Let's dissolve a little Nile blue in ethylene acetate, as well as make an aqueous solution of it, dissolve it in water. Now, when Nile blue is dissolved in water, it absorbs in the red and therefore it appears blue. On the other hand, when we put it in the ethyl acetate with a little base, then it absorbs in the green and appears red. Nile blue clearly dissolves in both ethyl acetate and water, but what about ethyl acetate and water? So we'll put a little of those two solutions in these cute little Erlenmeyer flasks. Gotta admit, that is some good looking labware there. And does ethyl acetate dissolve in water? Well, let's pour it in there, take a look at what happens, and sure enough, the two don't mix. So we form a non-ideal biphasic mixture. We get two layers, right? The denser layer goes to the bottom, the less dense layer stays on the top. Nile blue stays in solution in both, but the ethyl acetate solution goes to the top and the aqueous solution goes to the bottom. Now let's add some base, some aqueous sodium hydroxide. We'll put a couple of drops in here. It's an aqueous solution, so it's going to go right through the ethyl acetate, as we'll see. Come on, let's put a couple of drops in there. Thank you very much. Boom. Boom. Yep, now that we'll give it a swirl, make sure everything, and we will deprotonate. Upon mixing, we deprotonate the Nile blue, and we get it into the red form. What happens if we add some acids? Take some benzoic acid. That's a solid. We'll drop it in the top here, a couple of flakes. They go through the ethyl acetate again, and we'll swirl to get mixing. In the aqueous layer, we protonate the Nile blue, and once we protonate it, it turns blue. The benzoic acid protonates the Nile blue, turning it blue again. The basic ethyl acetate layer stays red. It's all down to this NH group at the end. If we protonate it to make it an NH2 plus group, then the Nile blue turns blue.